Hello all. In this video we're going to take a look at list methods. These are methods that the list data type provides that allow us to manipulate lists. And here is where, with a few exceptions, list methods and string methods are very different from each other. So even though these data types otherwise have really similar operators and really similar functions that operate on them, they are actually very different in some very fundamental ways, and that comes through when you look at the methods. So the string methods, remember, they always are building new strings, but they let us do all kinds of text manipulations. There aren't as many special purpose things like that for lists because lists are a generic data holder. A list holds any kind of data. It's just a container. We stick things in it. It's not as specialized as a string in its purpose. And that means that we don't just have a lot of methods that would be akin to the methods we have for strings. But the other main difference is strings are unchangeable. They are immutable. Lists are mutable. They are changeable. And because of that, many methods that lists have actually change the data in the list instead of building a new list. And we'll take a look at some examples of that as we go forward. All right, so I have here a list with just a simple example of most of the list methods we will ever need. There aren't nearly as many of them as there are string methods. It's quite limited. Again, you don't have to work to memorize them, although some of them we will use very, very often. So you should have certain methods at your fingertips. Other methods you'll look up when you need to know how to use them. I'm going to go through each of these in turn, doing some examples in just a minute or two. I do want to note that a similar list, with a few extensions, is also available in the Python documentation. You can see that they have a list of list methods. Some of these we are not looking at. Most of them we are, because that's really it. It's not nearly as long a list as string methods. And that's good for us. We don't have as many things to learn. So what I want to do is, I'm trying to figure out which of these looks easier to work with. Neither of them. Okay. What I'm going to do is maybe I'll take this example and we'll kind of work through it, but I'm going to go over to Python to do that so that we can actually run things and see the results. But there are a few categories here that I can point to. So there are two methods at the beginning, append and extend, that allow us to modify a list to add data to it. And I'm gonna make a little point here when we look at Python. We've seen the plus operator that allows us to concatenate, and that does allow us to make a list longer, but with plus we're always getting a new list. And here with these methods we're not getting a new list. It's the same list, we've just added data to it. And there's an underlying kind of difference there. We have a couple of methods here: insert, remove, pop. These allow us to add elements in the middle of the list or remove them from any position in the list. The remove method, in fact, is removing it by the data. So you can say remove the value 25 from this list and it will go find it and remove it, whereas the pop method is removing by position. We do have a couple of these like index and count that are very similar to what we have with strings. Index, it's a value, so it finds where this particular value occurs and tells you what position it is in. Count takes a piece of data and it counts how many times that value occurs. We have two that are very, very, very special to lists themselves. Well, I guess the third one is as well, although it crops up in a lot of other data types also. We have a method called sort, which will sort the data in the list in increasing order. It's not a good idea to do this when you have lists that have mixes of different kinds of data. It's okay if it's all like integers and floats. That's okay. But integers and strings, Python will do it. It will interpret an ordering two lists and strings together, but it may not make sense to you or I. So use sort when it's all one kind of data, like numbers or strings or something like that. But it is a method that will modify the string so that the data is in order. And there's some options you can use to actually sort in different orderings. Reverse, again, this is something that changes the string, or changes the list. It flips the data so that it's backwards. It just reverses the order of all the data in the list. The last one is super helpful, and we may have seen this one already in one place or another. There's a copy method, and this lets us make a full copy of the list. It's shallow in that it doesn't copy the sub values in the list, but it does make a new copy of a list that is separate from the original. That's important when you have something like a list that's changeable. Sometimes we might want to make changes but not to the original. We want to preserve the original and then make a copy and make changes to the copy. And the copy method lets us do that safely. All right, let's go to Python and try some of these examples out. All right, so list methods, I need a list. Let's make a list of numbers. Oh, I've been putting these in order. Let's not do that. Okay. They're still a little bit streaky in order, but that's okay. So we have a list with numbers in it. Some of the first ones that we looked at, let's see, what do I want to start with? Suppose I want to add some numbers to this list. If I want to add a single value to the list, we use append for that. Append for single values. So I can say nums, hold on, append, what's a good value? Nums.append 73, I'm going to print nums. And I'm just going to print nums over and over again. So notice I just put a piece of data here. It's a single piece of data. I have my original list that printed, and then there's a new version. Nums has changed. What I want to show you though is, let's suppose I'm going to comment this out. So I'm going, when I run it again, it'll go back to the original list, and then I'm going to say print nums plus 73, because we're like, we could do that. We've been using the plus operator to tack things onto lists before. So this, I have to put the square brackets there so that the plus operator has a list on one side and a list on the other. But this would work to add 73. So here I printed nums, then I printed it with the 73 added, and when I printed nums again, it wasn't there. Because this builds a new list that has a 73 added to the data from nums. It doesn't change nums. The only way I could actually get it to change nums is if I did it the way we've been doing it as an actual update step. Nums plus 73 reassigned to the nums variable. So we get rid of the old list and the new list goes into its place. That's actually a little tiny bit expensive in computer science terms. This would actually make it look like it's doing exactly the same thing. But we would prefer, if we want to change nums by adding a value to it, we prefer to use append because it's more efficient. Okay, that's the append operator. It's our friend. We like it. We use it a lot. Extend is not used as often, but it's also very useful. We use extend when we have multiple pieces. We have like a whole set of data in a list that we want to add to an existing list. All right, so I say nums.extend. I have the parentheses because it's a method call, and then I have a list inside, 42, 81, 93. So when I run this, I have the original value of the list, and then it has added all of those extra pieces at the end. So it's just a way to let you add multiple values at one time. All right, I'm going to then move on and we'll do some things that change nums. Let's say I want to add another value. I'm going to add the value 19 between, well, no, let's do something that isn't in order. I'm going to add the value 38 between the 16 and the 21. So I'm going to say nums.insert. And then we give it a position. 0, 1, 2. I want to put it at position 2. And the value I want, what did I say, is 38. Again, these are each modifying nums because nums is a list and it's changeable. So yes, I successfully did it. You want to, the index you give is the index of the value that's getting shifted. So the 38 went in place of the 21, and then the whole rest of the list was shifted out. So we can insert data. I can do nums.pop 6. So what does pop do? Pop takes in an index and it goes to that position and removes that value from the list. It's exactly the same as if we said del nums bracket 6. So why have it as a method? Because it's kind of nicer. A lot of people just prefer the method version. It lines up with other programming languages in certain ways. So the value that was at position 6, let's see, 0, 1, 2, 3, 4, 5, 6, that was the -3. Now the -3 is gone. If you don't give it anything, I believe it defaults to the end of the list, but I don't quote me on that. We could try it and see. Will it let me give it nothing at all? Yes. So if you don't give it an input, it will automatically remove something from the end of the list. Whatever is at the end goes away. The remove method, as I said before, looks for a particular piece of data. So I could say remove 50 and then take a look at the result. Now, as you're playing around with these, I strongly encourage you to make your own list and try these experiments, try to predict what is going to happen, and then run it and see if that actually works out for you. And if something doesn't make sense, then you can come and get some help. All right, so I said remove 50, and sure enough, we don't have an index of 50, but it went and found the value 50 and removed it. And similarly, like if I said before that, print nums.index 50, it would tell me what position 50 was at. 50 was at position 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a key. This list is not a very good one for me to show you this particular issue, so I'm going to make another list right here. All right, so I have this list. It has repeated numbers in it. What if I remove a 5 from here? 5. Can I type and do it? What's going to happen to the list? Will it remove all the 5s? One of the 5s? It only removed the first. So remove finds the first occurrence from the left and it takes it out of the list. All right, count, sort, and reverse are about all we've got left. I'm going to get rid of my little example here. I'm actually going to get rid of most of these changes we've been making to the list. Let's go back to the original nums that I typed. Um, counts the occurrences of the particular pieces of data. I think I'm going to skip that one, just showing you that one. What I want to do is to show you the sort. So we'll print the numbers before, we'll print them after. And then we'll reverse them and print them again. So this was our original list. When we sort it, it sorts it in increasing order. And then if I reverse it, I've got decreasing order if that's what I wanted instead. The only other thing of note is that copy method. So if I say nums2 equals nums.copy, then obviously changes I make to nums2 don't show up, right? So nums2 sub 0 equals a big weird number. So when you make a copy, then changes to the copy do not change the original. So this was our original, and you can see that the copy has the change but not the original. So it's very helpful, and you want to use this especially under circumstances where you might be changing the values in the list. All right, so this is a quick survey of list methods. They're less elaborate than string methods, but they are very powerful. And the key thing to notice is that they change, almost all of them change the list that you have. They don't make a new list, which is completely different than string methods. We're going to get some practice with these. We'll be using some of them over and over, and others we won't use very often, and you'll have to look them up when you need to actually find a use for them. But I think this is going to give us some more powerful things that we can do with lists and with strings. So I will see you all very soon.